We'll proceed in pseudo multivariate calculus. Pseudo multivariate calculus. This is our invention. This is not available in any of the book. That is pseudo multivariate calculus. Amazing, mind blowing. You can write we have a length vector. Oh, okay, we have a length vector, and then we have a area vector, and then we have a volume vector, we have a weight vector, and so on. Multivariate calculus. Multivariate means where there are more than one independent component, and that is called multivariate calculus. Multivariate, multivariable. Independent variables are more than one, and it is called multivariate calculus. Anyway, pseudo multivariate calculus. Whenever we are finding any trouble, when we are finding any trouble, then we go both for I'm sorry. When we are seeing any problem in mathematics, generally people try to find the solution through addition, subtraction, multiplication, division. This is the way people generally they try, or they try trigonometric, sinusoidal, or logarithmic, exponential. There are many functions. Okay, then slowly how I can transform it to calculus? How can I can transform it into the calculus? So that is an art that we are calling pseudo multivariate calculus. Like if I face any problem, generally we write pseudo code. Pseudo code means abstract code. Like anyone would say, okay, so like I'm I'm thinking, okay, I'm planting a tree. Okay, I'm planting a tree. Now when I'm planting the tree, then first I have to dig the soil. Okay, plow the soil. That is the first aim. Then I have to put manure. Okay, then I have to irrigate it. Then I have to put seed in it. Okay, that is the concept. When it start growing, then after some time flower will start coming. I have to keep irrigating at this duration. Then flower will come. Then I will cut here and there. Okay, does anyone thought that we are talking about which tree? If I am talking about any tree, then this is called pseudocode. Pseudocode means I wrote as an abstraction. Okay, if the planting a flower is completely different than any other tree, then I can write the pseudocode for the flower. From that code, what I have written, I will do some kind of customization for the flower. Again, I don't know which kind of flower it is. This is called pseudo code. Similarly, in mathematics, we develop pseudo code and without knowing that what's going on. And at the end, we will find that it will be solved through calculus and we will start changing it to calculus. In that sense, we have brought in length vector. Length vector is synonym to any line, any curve. Whatever the curve we have, wherever we find any distance, displacement, length, this kind of scenario, then we go with the length vector. Length vector is replacement of displacement, distance, length, whatever it is. There, we replace it with the length vector. Length vector is a vector. If I try to find its magnitude, it will give the length. Length vector is a vector. If I try to find its magnitude, it will give the length. That is one thing. Second thing is, since it is a vector, it will work with another vector. Like if I have a length vector and I am trying to calculate work done by a force. Force is a vector. Force dot product with the displacement vector is the net energy calculation work done. Force is a vector. Dot product with the length vector will give the net energy calculation. So any line, okay, if I have the way I always say, this is my line, and someone believes this is a line. Line is like this. This is a line and line is a curve, or this is a line, this is a line and line is a straight. Line can be in two types only. One is a straight line and one is a curved line. If I try to find distance between any 2 points on the line, any 2 point on the line, if I find distance between this point and this point, it will be termed as curve length. If I try to find distance between these 2 points, point and this point, this will be called curve length. Or if I try to find distance between these 2 points, it will be called line length. So what we came to know that if I try to find distance between origin, consider this is origin, and any point x comma y, then I can represent this line as a vector and find the magnitude of the vector, and that magnitude is the length of a line from one point to another point. Just represent the line through vector, and it works well with the curve line also. Okay, just represent the curve line through a vector and you calculate the magnitude of the vector, you will get the curve length. This vector is called length vector. It is not available in any of the book, anywhere in the internet, anywhere, called length vector. Wherever someone need to find the length of any segment, then that line segment represent the line segment through length vector, and you get the magnitude and you get the length of line vector. Is it really working? Indeed it works. Anyway, that is, if I represent this as a vector, then that is 0 0 x comma y, that is xi plus yj, that is same as I plus y by xj bracket close into x, same thing. Why I brought it in this situation? Because y by x is required. Because y by x, if this is x axis and this is the vector, this is the line, if this is the line and this is x axis, everywhere y by x is a number and it is constant. Like y equal to 4x, everywhere y by x is 4, everywhere. But if it is not a straight line, if it is not a straight line and this is x axis, then everywhere y by x is different. So I have to bring this length vector into y by x formula. That is I plus y by x j bracket close into x. This is called length vector. If I calculate the magnitude of this length vector, it will give the exact length of the curve. This curve can be like this, or this curve can be a straight line, whatever it is. Just calculate the magnitude of this vector, that is I plus y by xj bracket close into x. It will give the it will give the length of the curve. Now this length vector can be placed anywhere. What, where? If I need to calculate the area vector, if this is a surface, if this is a surface and this is the area, then this is the area. Area vector is perpendicular to the surface. This is area vector. This area vector, if there is an area, then it has two sides. Now I can calculate area vector, cross product of two length vector will give the area vector. Dot product of length vector with the force will give the work done. Cross product of two length vector will give the area vector. Area vector dot product with the length vector will give more or less volume vector, means volume. Okay, area vector cross product with again area vector will give the weight vector. Make sense? Anyway, now we are in phase of proving that now it's all right. Okay, now we will prove like Earth gravitational pull is path independent. Okay, the idea is how we calculate the, means what we are trying to prove. The idea is what we are trying to, how we are trying to calculate work done through length vector. Work done through length vector is force field dot product with the line vector. Force field vector dot product with the line vector will give the net work done by the force field. Okay, if this is the line vector, consider this is x square. The equation of this line vector is x square. I believe it is all right. I can consider the equation of this line vector is x square. Okay, so equation of this line vector is x square. This is x axis. Now I have an item that drops from here. If I put an item here, I believe many times I have showed it. So if I put any item here, okay. So if I put an item here, this is a log, and if I just drop it, up. If I just drop it, it falls in this path. If I just drop it, now I drop this log. Okay, it falls. Consider this point is origin. Then it falls from this point to origin automatically under the Earth gravitational pull. Okay, what is the work done that we are talking about? What is the work done under the Earth gravitational pull? Force vector dot product with the displacement vector. Displacement vector is displacement vector or force product, force force vector dot the displacement vector, or force into displacement is the net work done. So someone would start the algorithm how to calculate the work done by the earth. Earth is working here. If something is moving from one location to another location, someone is losing energy. That's why it is moving. Someone is working on it. Earth is working on it. If Earth is working on it, how much energy Earth is losing? That is force into displacement. That from there, the algorithm of mathematics start. Force into displacement. Later it becomes force, the force vector dot product with the displacement vector, because they should be in same direction. Force vector is there, dot product, length becomes displacement or displacement vector or length vector. Means if this is the force, what is the force? Down the line, here it is earth. Earth gravitational force is like this. Earth gravitational force is like this. In that sense, if Earth gravitational force is like this, then force vector dot product with the displacement. Displacement is happening through the line. If someone see it, displacement of this item is happening through the line. A line is a curved line. Force vector dot product with the line vector. Line should be a straight line. Then only I can do force, because force is a straight line. If this is x-axis and this is y-axis, force vector is along y-axis. Then displacement has to be a straight line. Then I can take cos theta or dot product of these two lines. But displacement is along a curve. Okay, whatever it is, if displacement is either curve or a straight line, I can use our generic length vector. So force vector dot product with the length vector started with the force into displacement is the work done. Force vector dot product with the displacement vector is the work done, where displacement vector is a straight line. Now force vector dot product, now with displacement vector, that is not a straight line, is a length vector, our length vector. So now this is the work done. What is the force vector of the earth gravitational pull? Minus gm minus gm minus gm minus gm is the, I'm sorry, minus gmm, that is the m, I'm sorry again, minus g, capital G is the earth gravitational constant, minus g m, that is the mass of the earth, and then m, mass of this item, by r square, or in vector term minus gmm r vector by r to the power 3. Minus gmm is constant, so I can just remove it. R vector by r to the power 3, that is xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2 minus. This is the earth gravitational pull. If it is going on only in y direction, I consider this as y. People may take as z also. I consider as y. Then x and z will go away. I and z component will go away. Now, in that sense, I consider this is x is 0 and this is x, this is y. Okay, so if I take this like this is x, this is y, this z is this direction. Okay, In that way, if it is falling, then consider z is 0, x is 0. Only y is there. Then it becomes yj by y to the power 3 by 2. Okay, in that sense, it will become j by y to y root of the y, j by root of the y. That is the gravitational pull of. Now it is difficult. What we are trying to prove here? We are trying to prove here that Earth gravitational pull is path independent. We know it. The formula, that is xi plus yj plus zk, that is the force formula. Xi plus yj plus zk, that is r vector, divided by r to the power 3, that is x square plus y square plus z square to the power 3 by 2. This pull is the force vector of the earth, dot with the this displacement vector is path independent. Dot displacement vector is path independent in the sense that whatever the we calculate, if I calculate force vector dot displacement vector, it will come in algebra, because dot product of I will bring algebra, plus dot product of J will bring algebra, and dot product with k and k will algebra. Net the integration will come as algebra. If I do the integration of this, then it will bring another result, that is algebra. Okay, if it is path independent, then whatever result we are getting, that result is only dependent upon the force, not on the path. Okay, means what I'm trying to say is that consider this path is, this point is x comma y, and this point is origin 0 comma 0. Okay, origin can be the center of the earth. Right now this is, or I can say this point is x2 comma y2, and this point is x1 comma y1. If I drop this item from x2 comma x2 comma y2, if I drop this item from x2 comma y2 to x1 comma y1, then how much energy earth is liberating to make this item move? This energy must be dependent only upon the begin point, that is x2 comma y2, and end point, that is x1 comma y1, not on the path. This is called path independent. Okay, if that is the case, if that is the case, then if I connect x2 y2, if I connect this x2 y2 and x1 y1 through a straight line, and then I make this item drop in a straight line. If I make this item drop in a straight line, then whatever energy it is earth is losing x2 y2 to x1 y1. If this item is moving in a straight line, then energy involved will be same as this item moves in a curved line from same begin point to the same end point. The energy calculation should be same. Or someone drops the item like this, and then it goes like this. But if it is earth gravitational pull, then I believe the x2 y2, that is the point. If I drop it vertical, then this point will be x2 comma y1. If it is earth gravitational pull, then no need to go horizontal, I believe, because it is in j direction only, whatever it is. Now it falls like this, or if I take path like a vertical and then horizontal to x1, whatever path I take, straight line, vertical line, and then horizontal line, or through a curved line, whatever path I take, net energy calculation should be same. Okay, what are you talking about? I am talking about force vector dot product with the length vector that we are talking, that calculate the energy. What is the force vector? Force vector is xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. I know this earth gravitational force vector is path independent. In that sense, if I do dot product with the length vector, what is the length vector when this path is y equal to x square? Consider this is x-axis. If this is x-axis, then this path is y equal to x square. In that sense, length vector is I plus y by x. Y by x, since y is dependent upon denominator x, it will be termed as dy by dx. Y by x, so I plus dy by dx j. bracket close into x, x will be termed as dx because this term and x are multiplication and right hand side it is independent component. Multiplication of two items where one item will function over another item and that is independent component, it will resolve into integral calculus. This is pseudo mathematics. We started with the energy that is force into displacement. We came to force vector dot displacement vector, that is displacement is straight line, to force vector dot length vector. Now the net calculation is xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2 dot product with I plus dy by dxj bracket close dx. This is the net energy calculation. dx is the dx is the length strip that it length strip of on the x-axis that it is moving. Makes sense? If I am dropping an item from point x2 y2 to point x1 y1, then dx, the length along the x-axis is x2 minus x1. That is dx or x. Earlier it was x, I plus y by xj multiplied by x. That x was the distance on the x-axis, that is x2 minus x1. Now that will come as a limit x1 to x2 and then x1 to x2 and then xi plus yj plus zk by x square plus y square plus z square to the power 3 by 2 I plus dy by dx. Y is x square because I have taken it as y equal to x square. That is the curve equation. Dy by dx, that is 2xj. So I plus 2xj dot into dx. Now whole will be resolved as x I and I dot product will be x. X by x square plus y square plus z square to the power 3 by 2 plus y into 2x. Now y is, if I take the y along this length, y will be x square. It will be 2x into x square, 2x to the power 3 dx by x square plus y square plus z square to the power 3 by 2. Now it is up to me. If I take that it is only j component is there, x component is not there, then I factor will go away. Only j will remain, whatever it is. If I don't see in that fashion, then it will be x by x square plus y square plus z square to the power 3 by 2. 3 by 2 is only in the denominator. Dx plus 2x to the power 3 by x square plus y square plus z square to the power 3 by 2 dx. Now this I have to calculate, and where x is x1 to x2. Okay, if I calculate this, then I'll get the net energy calculation. Now leave it. Whatever I get, that is the net energy calculation along this curve. Now, what about net energy calculation along this straight line? That is x2 yt to x1 y1. Okay, what is this straight line? This straight line is y2 minus y equal to y2 minus y1 by x2 minus x1 into x. That is the equation of the line. If it is a straight line, then again we will start the same formula. xi plus yj plus zk by x square plus y square plus z square to the power 3 by 2 to the power 3 by 2 dot product with I plus dy by dx. dy by dx, y equal to y2 minus y1 by x2 minus x1 x. dy by dx will become y2 minus y1 by x2 minus x1 j and dx. Now settle it down and calculate it for x1 to x2 as dx. Now see how much is the energy comes. Now take another path, that is a vertical straight line and horizontal line. Vertical straight line, that is from x2 y2 to point x2 y1, and then straight line x2 y1 to x1 y1, because that is also a path. Now again calculate it. Now if I take this vertical line and horizontal line, what will be dy by dx? dy by dx for the vertical line is infinite and dy by dx for horizontal line is 0. because y is not changing when we are changing x. So dy by dx is 0. Whereas for vertical line, if you make a slight change in x, y will change infinite. So dy by dx is infinite. Anyway, okay, so we will proceed it, but we will take different formula for the force because this force formula is very complex. Xi plus yj plus zk by x square plus y square plus z square to the power 3 by 2. This formula is very complex. So this formula is called path independent. We know it. The force of earth gravitational force is path independent. How we know it is path independent is if I have a force, if I have a force vector dot product with the length vector, it will come as algebra that we have seen. I dot I becomes a algebra plus J dot J becomes algebra, K dot K becomes algebra, addition of all becomes algebra, dx. Now this whole result becomes another algebra, that is the energy calculation. Okay, if this energy calculation what we are making, the energy calculation what we are making, this energy calculation for different kind of path, if it is same, then energy calculation is only dependent upon the force, not on the path, because for every kind of path, this energy calculation from limit one limit to another limit is same. Okay, mathematically how it is proved? Mathematically it is proved in a way that force vector dot displacement vector, if this integration brings, if this integration, I'm sorry, consider this integration brings a algebraic function that is g, that is g. If I differentiate g with the x, partial differentiation dg by dx, and it becomes force vector x component. The result, the force vector dot displacement vector, whatever the result is, if I integrate that, it comes as another vector, another algebraic equation that is called potential function. Because potential function, if I set limit from one limit to another limit, or potential energy, this is a better word. Force vector dot displacement vector, if I do this integration, it will brings potential energy function. Now limit from one limit to another limit, that is potential energy difference from one limit to another limit, will give the net energy. Okay. Now, if whatever potential energy function what we are getting as algebraic function, that is g, if I do dg by dx, and it becomes the x component of the force. What is x component of the force of the Earth's gravitational pull? That is x by x square plus y square plus z square to the power 3 by 2. If I do dg by dy and it becomes y component of Earth gravitational pull, then it is y by x square plus y square plus z square to the power 3 by 2. Because Earth gravitational pull is xi plus yj plus zk by x square plus y square plus z square to the power 3 by 2, or r vector by r to the power 3 minus gmm r vector by r to the power 3. That is the Earth gravitational pull. In that sense, the x component of Earth gravitational pull is x by x square plus y square plus z square to the power 3 by 2. Y component is y by x square plus y square plus z square to the power 3 by 2. Zk component is z by x square plus y square plus z square to the power 3 by 2. If I integrate this force vector dot displacement vector, this integration brings g function, that is gravitational energy function. dg by dx is x component of the Earth gravitational force. dg by dy is y component of the Earth gravitational force. dg by dz is z component of gravitational force. Then the g, that is the net result of this integration, is only dependent upon the force field, not on the path. Then it is path independent. We'll take another example, which is simple. Consider Earth gravitational force is xi plus yj. Simply xi plus yj. Now it is in xi plus yj plus zk. xi plus yj plus zk. If I have a if I have a potential function called x square by 2, plus y square by 2 plus z square by 2. This is the net energy calculation that came after force vector dot displacement vector integration. This is the net potential energy x square by 2 plus y square by 2 plus z square by 2, where force vector is xi plus yj plus zk. Now this is the energy potential energy function. Now d potential energy function by dx will become x. D potential energy function by dy will become y. D potential energy function by dz will become z. In that sense, what is now if I say my potential energy function is x square by 2 plus y square by 2 plus z square by 2, then dg by dx is potential energy function g. dg by dx is x, dg by dy is y, dg by dz is z. In that sense, these three are x, y, z are the x, y, z component of the force field, that is xi plus yj plus zk. Means if I have a force field xi plus yj plus zk dot product with the displacement vector, if I want to calculate this full integration and from the somewhere in the universe I am getting one algebraic function for which partial differentiation is exactly force field, then this will be the net integration. That is for sure. Do whatever you can do. And this is called path independent because net result, that is x square by 2 plus y square by 2 plus z square by 2, it is only the partial differentiation of this with x, y, z is only dependent upon force because it is exactly matching to the force field. This is called path independence. Not every force field will generate an algebraic equation for which partial differentiation will come back to the force field. Not possible. Everything is not possible. There are only few force fields for which there is a algebraic function exists for which partial derivatives are again force field. This is called path independence because result is only dependent upon the force. So we will take another force field which is simple to calculate, and that is path independent. Idea is to prove that path independent works with our length vector concept. The length vector fundamental we are introducing is pseudo multivariable calculus. Pseudo multivariable calculus, that length vector will work. That length vector will work with this concept also. Now we have force field as xi plus yj plus zk. This is also path independent in similar to xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. What is the potential function for xi plus yj plus zk by x square plus y square plus z square to the power 3 by 2? It is r vector by d by r to the power 3 or r unit vector by r to r square. This, if I calculate a potential function that is minus 1 by r, consider there is a potential function called minus 1 by r. If I differentiate minus 1 by, I'm sorry, okay, we have force field as 1 by r square, 1 by r square, 1 by r square, then it will be potential function, consider it is minus 1 by r. Now differentiate minus 1 by r with the r, then it will become 1 by r square. Means 1 by r is the potential function exists for which the force field is minus 1 by r square. So it exists. Someone can calculate in algebra also. In algebra, 1 by minus 1 by r becomes minus 1 by x square plus y square plus z square to the power 1 by 2. R is x square plus y square plus z square to the power 1 by 2. If I say, if I have a force field that is minus, that is 1 by r square, r unit vector, 1 by r square is my force field, then what is the potential energy function? Because there should be a potential energy function exist for which partial derivative is the force field. If that is true, then net energy calculation is dependent only upon the force field, and that is minus 1 by x square plus y square plus z square to the power 3 by 2. Now let's calculate partial derivative with x. This by dx minus 1 by x square plus y square plus z square to the power 1 by 2 by dx, then it will it will become, I believe, to the power minus 1 by 2. Minus 1 by 2, and minus is there. Minus 1 by 2 will come outside, and it will become 1 by x square plus y square plus z square to the power 3 by 2 into 2x. 2 to gone, minus minus gone. It will come as x by x square plus y square plus z square for 3 by 2, means d of potential function by d of potential function by dx is the x component of the force, that is x by x square plus y square plus z square to the power 3 by 2. Similarly, y component, z component, they will come like that. So the function minus 1 by r, that is the potential function, is a potential function, or minus 1 by x square plus y square plus z square to the power 1 by 2 is the potential function for the force field, earth gravitational force field. Means their potential function exists, for which partial derivatives are force field, means earth gravitational pull is path independent. I believe this is long time. We will probably proceed on this with the earth gravitational pull is xi plus yj plus zk from a point called 4,16. Consider this is y equal to x square. This is y equal to x square. And there is a point here called 4,16. Possible, right? If on x-axis, if x is 4, then height will be 16, y equal to x square. Consider our item is dropping from 4,16 to 0,0. Now calculate the energy calculation through any path independent force field, that is xi plus yj plus zk. Now consider through our length vector xi plus yj plus zk dot product with the length vector, that is I plus dy by dxj bracket close into dx. Okay, consider this is xy plane. Okay, not xz plane, xy plane. Consider this is xy plane. In that plane, calculate the energy calculation, that is xi plus yj plus zk, that is force field dot product with the length vector what we have proposed, I plus dy by dxj into dx. If I just calculate the magnitude of length vector, it will give the length of this vector from point 4,16 to 0,0. If I do dot product of this length vector with the force vector, it will give the net energy calculation. Now, idea is to calculate this length vector dot force vector and calculate the energy calculation from point 4,16 to origin with this line, and then through the straight line, and then through this third path, that is vertical and horizontal. If all three comes as same, then it will give a hint that our length vector is completely all right, because this is what is expected, that energy calculation from any two point in a force field that is path independent, it should be same. Doesn't matter, you take y equal to x square, y equal to 4x, that will be this line, or x equal to 4 and y equal to 0. You take this path also, take any path, it should be same. If we are take three example and it is same, then we will try with the generic proof, and then our length vector is fool proof. That is the concept. We will proceed on this. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9 plus 91 is the India country code. 9483160610 is the telephone number.